Okay, what we're going to do here is we're going to look at another form of graphing, and it's called a stem and leaf plot. It's really popular in observational science, and it does create histograms. It creates histograms on the fly, and it's used a lot in the biological sciences and anything where observational surveys are being or observational research is being done, where you want to see what your data is doing before as you're taking it. And so how it works, use a data set here. 18, 19, 22, 23. Now I'm putting the data in numerical order. 8, 29. We'll repeat 29 twice. And then 30, 31, 35, 42. And so what you do is you focus on the digits of the number. So you have the grouping for the tens, for the 20s, the 30s, and the 40s. And those groupings, instead of counting up what you have, you write down the other digit. So 8, 9, 2, 3, 7, 8, 9, 9, 0, 1, 5, and 2. So right, we kept track of each digit. What's nice about stem and leaf plots, stem and leaf, is that you've kept track of all your data. In histograms, you lose what the values were that came in there. You just know how much was in a bin, but you don't know where it was in the bin. Here, I have 18, I have 19, I have 22, I have 23, I have 27. Your data is recorded. And if you kind of look at it on the side, it does show you the shape, like a histogram. Right? You flip this over and it would look like a histogram. So it has some of the behavior of a histogram. It preserves the data, and so you can make a stem and leaf as you're collecting your data to get an idea of how your data is organizing itself. It suffers from a problem that all the bins are limited by how we count based on our number, and sometimes our data doesn't group like that. Sometimes the data is grouped in ways that controlling the width and having it based around where the data is at will show a better description than the numbers 0 through 9. The other problem with it is the bins are the exact same size, or always 10. And so if your data is really crowded within the tens, you're not going to see any patterns in there by breaking up the bin sizes. There is a variation of this, and let's look at this variation with some data here. So I'm going to refer to slide 6 in the section 2, chapter 2, section 2, which has the number of text messages sent. And so it's 50 pieces of data on users where they had 50 users that sent text messages, and it says how many messages each user has sent. And what I'm going to do is I'm going to use an expanded stem and leaf plot. So what I'm going to do is I'm going to look again at this data. Let me pull back to it, and I think the lowest number on this, let me see if I can find it in here, is 16, I think. Yeah, there's 16. I don't think anything lower than 16, and 149 is the largest. And so what I'm going to need is I'm going to need 1 through 14 to cover the digits that I'm looking at. So, whoops, I was trying to show this and I didn't, so let me try that again. There's 149, the largest number, and 16 is the lowest. So looking at that data, I need to get the digits to cover that. And what I'm going to do is I'm going to do this on a small level so that I can see everything that's happening, or see things happening a little bit better. So what I want to do is I'm going to break my digits into 1 through 4. Whoops, 3, 4, and 5, 6, 7, 8, 9. So what I'm going to do is I'm going to have an upper, or a lower, and an upper for each one. And so I'm going to need 14 of these, or I'm going to need to go up to the number 14. Hopefully I'll have space on here. Ten, 10, 11, 11, 12, 12, 13, 13, 14, and my last 14 down there. I'll just squeeze it into the bottom. I think you guys can barely see that last 14 coming down. And again, if we look at the data, I want to pick numbers and fill them in. So I'm going to go through it and fill in these numbers using this next digit and making sure that they fill into the places that we need to. So when I look at the data, my smallest number is 16. So that goes here with a 6. If I go through the data, I see a 19. Double check. I don't see anything more in the upper halves of the tens. I had nothing in the lowers. Now my 20s, if I look for the lowers, there's a 20, a 23, and a 24. So I'm scanning through the data looking for patterns. And so what I'm going to do is I'm going to fill in the digits representing all the data. There's a lot of 29s in this data. And a lot of 33s. 38, 39. And again, this is the same as the other stem and leaf plot, but it's broken each tens place into 2. And let me just fill in the rest of the data, but I'm pulling these numbers off of the list here. And the thing you can sometimes do is if you have your things in technology, you can put them in order. And when you do it in order, these things are a little bit easier to see. And so I like putting them into spreadsheets and then having them ordered. There's nothing in the lower 90s. No, nothing in the lower 90s. 102. And then in 115, 122. And then in our 149 at the end. Now, the thing to kind of look at is if we think about if we turn this on the side, it looks like a histogram. It's kind of describing all of its data coming through here. And stem and leaf plots are really good at this. And so some of the patterns we can see here is, well, there's definitely a bump here. And there's another bump out here. And what we're going to find out when we have two modes, or two areas where the data it kind of centralizes, this is going to be bimodal. Now, text messages are here, most of the stuff's between 20 and 80. There's some outliers. Now, text messages used to be expensive. And so people wouldn't send as much before unlimited plans became a thing. And I would actually posit that these were people that had different rates or different means, right? The people here had more money and these had less money, or at least or were more frugal with their money and limited their text messages. And when they tended to limit. Really looks like it's around 30, right? Because these numbers are really close to 30. Who knows? Maybe the plan had a boundary that, you got so much up to 30, and then after 30 there was an additional cost. And then over here, these people didn't worry so much about the limit, or they had the extra money to spend, or they used it a lot for work. And that in itself seemed to center around 76-ish. but there's definitely two groupings of behavior in text messages here. And then out here are people that are just going nuts with it, using it a lot. And so this is a stem and leaf plot. All right, I am not going to discuss the dot plots. They're very similar to stem and leaf. You use a dot instead of the numbers coming out. They're really good to do on a piece of graph paper. I think you can read through the dot plots in the book. But stem and leaf get a lot of usage because you can write these numbers down as you're observing, and you get a feel for where your data is bulking up before you even go back and enter it and do any calculations on it, because it's creating the visuals right away. And it does preserve the data values in it. Big problem is you have no control over the boundaries. At the best, you can divide things like we did into two groupings like we did there, or smaller groupings.